All right, section 1.4. It's going to deal with a couple things we've talked about before. Let's just review very, very quickly. If I had that right there, what is that thing right there? That's a line. Okay, if we were to label a line, call that AB, what would I call this line? Line AB. So I put a capital A and B and put a little line symbol over top of it. Everybody good with that? All right, that's easy enough. Let's do another one. What if we had something like this? And then I call this XY. Right, the X and the Y are endpoints. That's good. And then what would I name this thing? Line segment XY. The line segment symbol is just that. Okay? No arrows. Is that what you said? Yep, no arrows on the end. Just a line. No dots. Don't put the dots on the symbol. Just put a little line. Okay? Now, I could name this something else. What else could I name this line up here? BA. Yeah, line BA. Or I could name this line segment what? YX. Okay? All right. Good to go, right? So what we're going to do now is we're going to do kind of a thing that's kind of a combination. Fred, are you with me? You're not going to say what, are you? You kidding me? You're not going to ask me what when your forehead is on your book and you're going to say what? Come on. Think about it. I know. Watch this. We'll call this, I don't know, let's call it something else. Put a P and an R. Now look at this. This is kind of like a combination of the two of those, isn't it? Because look, I have an endpoint, but I only have one endpoint. I don't have two endpoints. I have an arrow, but I only have one arrow. I don't have two arrows. So it only goes in one direction. Okay, it only goes in one direction, but it does have a starting point, doesn't it? All right. I had somebody in other class say, well, why don't you call that the beginning point or the start point instead of the end point? Well, don't think of it, this is where it ends. Think of it as this is just the end of the line segment or whatever, okay? This is not a line segment, though. We call this, and you've probably heard this before, we call this thing array. So we call it array. And so this endpoint right here is very, very important. This endpoint, now remember when we did the, just 2 seconds ago, basically, when we did the line and we did the line segment, it didn't matter if you called this line AB or line BA. Didn't make any difference, okay? Because there was no beginning or there was no end. Right here, it doesn't make any difference, okay? You can go from left to right or right to left. It doesn't make any difference. I could have called it line segment YX. On array, though, it does matter, okay? It absolutely matters where you start, and you always start. You might want to write this down. You'll always start at the end point, okay? That's where you always start labeling array. So array is always labeled by the endpoint first. So it absolutely matters which one goes first, unlike a line or a line segment. So if I wanted to call this something, I would call this ray. Now where do I start? What would be my first letter? What is it? P, right. So it's P. And then the second point, you still use 2 points. Second point is just one point that the ray goes through. And give me a point that the ray actually passes through. R. So I'm going to call this ray PR. Now watch my symbol. Symbol looks just like that picture. Okay, it looks just like that. Just with a little arrow. Now it doesn't matter if this ray goes up and down, left, right to left, or diagonally or anything else. Look, I could have a ray that looks like this. And we'll call this like MN. Alright, what would I call this ray right here? Ray what? MN. Okay, it has to start at M because that's the end point. Now, because this thing's going diagonal, you don't write your little symbol like that. I had somebody last year try that. Okay, they always put it the direction of whatever the ray was going, but it doesn't go like that. The symbol for the ray always stays the same, and it always goes like this. Okay, it doesn't matter which direction your actual ray is going. The ray symbol will always look like this right here. Make sense? All right. So, say what? Hold up. Okay. I mean, I didn't write too much on there. All right, so let's see what else I want to do with this. Oh, okay, I know what we'll do. Let's do this. Watch. Let's stick another letter. Let's use this ray up here. Let's not use this one. I'll get rid of that. Look at this. Let's call this Q. All right. So remember before. Now I didn't change the ray at all. All right. Still has the same endpoint. Still goes through point R, but it also goes through another point that I've labeled, which is point Q. Now remember, somebody asked me, do you just use 2 points? Yes. On a ray, you only use 2 points. The first one has to be the end point. The other point that you're going to use has to be a point that the ray goes through. All right, so what points does this ray go through? Q and R. So really, I have an option here. I could call it ray PR because it starts at P and it goes through R. Or I could call it what? PQ. That's good. Okay, I could call it ray PQ. They're the same exact ray. Do you see that? It's just another way to name that particular ray. I could have a dozen points in here. All right? As long as I start with P and pick any point that it goes through, I've named the ray properly. Make sense? We're going to be doing this a lot, labeling rays and things like that. So make sure that you understand what's going on there. All right. Sometimes you'll see this. You'll see a ray going this way. And here's the end point. And then you'll see a ray starting at that same end point, but going in the exact opposite direction. Now, they're 2 different rays. All right? There's still 2 different rays, but we call these things opposite rays. It's a terrible E. Let's try this again. It's terrible everything on this letter. Okay. Oh, goodness. Forget it. Let's do this. I'll start again. Opposite rays. Don't know why I had trouble with that. Okay, they're called opposite rays because they're going in complete opposite direction. You see that? One's going this way, one's going in the complete opposite direction. Now, this would not be opposite rays. Watch, if you had a ray like this, and then you had a ray like that. Okay, well, these are 2 different rays, but look, this is going in the exact opposite direction as this is. Is this going in the exact opposite direction as this right here? No, it's not. All right, so this is not an opposite ray. This is an opposite ray. Now, you may have learned about this kind of stuff earlier before you took geometry, but I'll tell you what, I'm not going to get into that yet because I'm almost ready to do that. Almost got ahead of myself. Let's do this. So we did the opposite ray thing. Let's do another couple rays. Okay, so here's a ray right here. I'm going to start from that end point again, but I'm not going to go opposite. I'm just going to take it up like this. Okay? Now look what we have. We still have 2 rays, don't we? Let's actually label these rays. I'll call that A, call that B, call this C. So what would the 2 rays actually be right here? Okay, BA, good. So ray BA, and what's the other ray? Ray BC. Everybody seeing that? Because you got to start with the endpoint, don't you? Can you call it ray AB? No, because A is not the endpoint. It goes through A, so you got to start at the endpoint and go through. So we've got 2 rays right here, and they're connected. They both share a common endpoint, which means they share the same endpoint, don't they? Point B is the endpoint to this ray. Point B is also the endpoint to this bottom ray right here. So they share the same endpoint. This whole thing, this whole 2-ray thing connected by a common endpoint, that whole situation right here has a name as well. And you probably learned this. What do you think that whole thing right there is called? An angle. Very good. All right, so that's an angle. This whole thing, the 2 rays with a common endpoint, that's basically the definition of an angle. 2 rays that share a common endpoint. Anybody writing any of this down? I'm saying a lot of stuff, and a lot of people are just sitting there staring at me. Write the stuff down. This is how you take notes. Pencil in hand, write the stuff down. Don't flip through your book. Put a pencil in your hand and write the stuff down. Let's do it. Come on. So this thing right here is called an angle. We got to name the angle, and we got to label the angle. So let's learn how to do that before we talk about some other things. Actually, let's do this first. See that point, that common endpoint right here? We give that a special name as well, and that's called a vertex. So when 2 rays come together at a common endpoint, that point where they come together at, that's the vertex. So point B is the vertex. That could be a quiz question, could be a test question. I could say, what is the vertex of this angle? And you would say, what? B, point B. All right. I could ask you the 2 rays. These actually have names. We call this the side of the angle. And this right here is the side of the angle as well. So I could ask you a question where it says name the two sides of this angle. The two sides of the angle would be ray BA and ray BC. All right, so if I ask for a side is a ray. Jot that down. Write it down in your notes. If I say something important like that, write it down. So if I said, what are the sides of the angles? You wouldn't just say BA, you would say what? Ray BA and ray BC. All right? And this is how you would write it. Don't write the word ray in front of it and then write BA. This is how you're going to write it, just like this. Same thing with lines. Don't write the word line. If I said line AB, you put an AB and the line symbol over top of it. All right, so we're kind of dissecting. We're taking apart this angle, and we're finding all the different parts to this. All right, so this whole thing's called an angle. Now we can label and name the angle. Remember, on a ray, the endpoint had to be the first letter. Remember that, don't you? Okay, so the endpoint has to be the first letter on a ray. On an angle, the vertex, we're going to actually use 3 letters to describe an angle. The vertex is always going to be in the middle. Write that down. On an angle, when you label an angle, the vertex is always the middle letter. Write it down. The vertex is always the middle letter. So if we wanted to name this thing, watch the angle symbol. Kind of looks like this angle. It's kind of like an L, but a little bit slanted. All right, that's our symbol for angle. So write that down. So we would call this angle what? If the vertex always has to be in the middle, and here's a point A and here's a point C, what do you think we could call this angle? Angle what? Now we use 3 letters, I said. ABC. That's right. Call it angle ABC. Now, Justin, you're not wrong in saying angle B, but I want us to first label it with 3 letters. Okay? Here's another way we could name it. What do you think? There's another. What other? Could you say ACB? Why not? Because what has to be in the middle? What has to be in the middle? The vertex. So the B has to be in the middle, but there is another way to name this. CBA. That's right. So I could name it angle CBA. All right. So it doesn't matter which order I go. I could go A, B, and C, or CBA. Is that making sense? And you think, what does this matter in the grand scheme of my life? Okay, this in and of itself doesn't. But we're going to be doing a lot of stuff all year long. We're going to ask you, or I'll tell you about this certain angle. I'll say, look at angle XYZ. So you're going to need to know exactly which angle that I'm talking about when I say, look at angle XYZ. All right? And you're going to be doing this really the rest of the year. So right now is so important because it's not just going to stop after this lesson. It's going to continue with almost every single lesson we're going to do the rest of the year. Okay, we're going to need to know how to label angles and rays and line segments and lines and all that thing. Okay, so make sure that you're paying attention and you know what's going on here. Now here's another or. If you wanted to make this a little easier, as long as there's only one angle right here, I could just call it by its vertex. So its vertex is B, so I could call it just angle B. But I'm going to show you something in a couple minutes that sometimes you can't just always name it by one letter. All right? There are times when you can't just name it angle B. In this situation, you're fine. You could call it just angle B. I'll show you in a short amount of time here that there are situations where you can't just use that one letter. All right? Now, this is kind of interesting. Sometimes you'll see angles and they'll stick a number in there. I used a 1 in the last class, so let me just be a little different. What if I put a 2 right here? That doesn't mean like how many degrees it is or anything like that. It's another way to name this angle. So look, I got 1, 2, 3, 4 different ways that I could name this angle with all this stuff that's given right here. I could call it angle ABC. I could call it angle CBA. I could call it angle B. Or, guess what? I could call it angle what? 2. Right. I could just call it angle 2. I always like that when they do that. When they stick the numbers in there, it's a little easier so I don't have all these letters going all over the place. Sometimes it's really nice when they stick a number in there, and then you could just call it angle 2. How do you know this angle is angle 2? Because it's between those 2 rays. Do you see it? The 2 is between there, so I could just call it angle 2. It's kind of one of my favorite ways to call an angle, is when they put numbers in there like this. So that's all we're doing right now. It's real no math. really involved. It's just learning labeling. It's just labeling stuff, learning a language, right? We're just learning the language of geometry, and that's what we're doing here. Okay. Um, let's see what else. I didn't hit this in the last class. I'll tell you what. Let's do this. This isn't that big of a deal, but if I had a point right here, do you think that point's inside the angle or outside the angle or on the angle? This point right here, it's outside the angle? Really? When I think about the angle, I'm thinking all this stuff between the two rays. I would consider all that stuff to be what? Yeah, I would think it's inside the angle. You don't agree? That looks outside the angle to you? I think that looks inside to me, doesn't it? It's in between the two rays, so it's in the angle? Yeah, I think so. So we don't say it's inside, but we use a point, or we use a word, interior. We call that the interior of the angle. So any point inside, in between those two rays right here, would be in the interior of the angle. Well, what if I stuck a point out here like this? Where do you think that would be? Right, if that's the interior, this would be the exterior. All right? Again, it's just vocab. Just learning words, right? Okay. What we want to do, though, now is we want to measure that angle. We need a way to measure it. Now, we've already measured some things, like a line segment, right? We've measured it in centimeters and inches and things like that. We've already done some measurement, but we have to measure an angle. Measure an angle. We don't measure it with centimeters and inches, and you probably already know this before this class even started. What do you think you measure angles in? Degrees. Very good. And I just happen to have a little cool thing right here that I grabbed off the internet. I think it's fitting in my little box. It might be a little bit off center, but that's good enough. Look at this. This is kind of cool. I just found this the other day. I was looking for something. We measure it with angles. And what is this little device right here called? The word's actually in front of you. It's a protractor right there. Okay, it's called a protractor. We use a protractor to measure angles. All right, look, and it says drag and drop the protractor to measure the angle ABC. So here's A. Look what they did. They put B in the middle, didn't they? Just like we said, C. So what I'm going to do is this. The protractor. See where the X and Y axis come together right at that point? See where that finger is? Right there? Okay, that's where I put that at the vertex. So I put it right at the vertex. All right? Thank you. And I make sure that one of the line on the protractor lines up with one of the lines on the angle itself. All right, so I make sure it lines up, put that right there, and now we got to figure out how long is that, or what's the measurement of that angle. Well, here it starts at 0, and then it goes to 10, 20, 30, all the way around to what? 110, a little bit more than 110. Which one? It's definitely not 33, right? So it's either 114 or 117. Looks like it's closer to 114, doesn't it? So let's click on that, and yeah, oh, look at that. You're good. I knew that. Yeah, let's do a couple more. We don't, because they're all kind of the same. But watch, if we do that one right there, look at this angle. This angle doesn't go as far over, does it? So it's a little bit shorter. It goes from 0 to what? To 40. So I think 40 is good, right? Right there. Oh, here's another one. Look kind of the same, doesn't it? But we put the protractor on there. It's not quite the same. It's close. Yeah, 35, 36. Okay, so this is definitely the closest one, isn't it? Okay, so 36. Click that. Now watch this. Just look at the protractor. Let's put it down here so I can see it. Down here, that's 0, isn't it? Up here is how many degrees? 90. And all the way down to here is 180. What if I went straight down like this? It'd be 180 plus what? Another 90, which is 270. Good. It's 270. So if this went straight down like that, that would be 270. Watch. If I start here and I go all the way around, how many degrees would that be? 360. Okay? All the way around one circle, right? Right? 360 dunk. You've heard of that all the time, right? Or skateboarders do 360s and all that kind of thing, right? That's one full rotation around, isn't it? That's where they get it from. It's 360 degrees. You got it? Without this protractor, what do you think this measurement is right here? Do you think it's 175? You do? Because look, 90 would go straight up here, wouldn't it? Is that more than 90 or less than 90? It's less than 90, okay? So, but it's not a whole lot less than 90, because 19 would be way down here like this, wouldn't it? So probably, I'd say 69. Yep, very good. What about this one right here? What do you think that is? It's probably 77. Yep. What about that one? That's a little bit trickier because look, it definitely looks more than 93. It looks 114 or 106. I don't know. I'm not really sure. So let's put the protractor up here. Put it right there. What do you think it is? Yeah, it looks like 114. Yeah. All right. What do you think that one is? Yeah, because it's not 91 because 91 would go straight up and then this way just a little bit more, right? Definitely not 102. So I would say 78. What about this one real quick? 10. What do you think that one would be? Yeah, I'd say 67. Good. Probably 43. Yeah, because 87 would be really close to 90, wouldn't it? And it's definitely not 102. All right, you get the idea, don't you? Okay. Now we have words for these. Let's start with the 90 first. Okay. Watch this. So this is, if I put a little box right there, that little box indicates that it's 90 degrees. So if I have an angle that's 90 degrees, I call that a right angle. And I'll put the angle symbol there instead of writing out the word angle. So a right angle is equal to 90 degrees, isn't it? What if I had an angle that looks like this? Is that more than or less than 90? It's less than 90 because 90 would go up here. This is less than 90. So we call this an acute angle. All right, an acute angle. And that would be what? Equals less than 90 degrees. All right, and you've heard these words before, right? You did this in regular maths, didn't you? Before you even heard of geometry, you probably learned this stuff. What about this angle right here? This is more than 90 degrees, isn't it? So we call this obtuse. So it's an obtuse angle, which is more than 90 degrees. And you think that might be it, but you've got this one right here. A lot of people don't even think of this as an angle. Now, we've already talked about it a little bit today, if you remember. There's one ray, because an angle is made up of two rays, isn't it? Shared by a... I'll tell you what, let's do this in a different color just so you see the difference. Okay? Now look at this. These two rays are completely what to each other? We used this word earlier today. Opposite. So they're opposite rays, but they also form an angle. Because if I went straight up and down, that would be how many degrees? 90. We saw this on the protractor. If I went all the way down to here to make a straight line, how many degrees is that? So from there to there is 180 degrees. So a 180 degree angle actually forms a straight line, doesn't it? In fact, we call it a straight angle. So that is an angle. A lot of times people don't think straight lines are angles, but they really are. They're two rays, common vertex right there, right? Common point, end point, and it forms 180 degrees. The degree symbol is that little zero looking thing up there. That's 180 degrees. That's not so hard, is it? Okay. I think that pretty much covers it. So let me give you a worksheet before you go.